Hi, welcome to this new video. We're going to discuss in this one from exercises 1 to 5, the chapter 18. This is the chapter of the markets for the factors of production. This is a book of Gregory Mankiw, Principles of Economics. So the first question says that suppose that the president proposes a new law aimed at reducing healthcare costs. All the Americans are required to eat one apple daily. So the first question says, how would this apple a day law affect the demand and equilibrium price of apples? So before going to this question, I would assume something. So we assume that this behavior is forced because before the consumption was low. So that's the basic frame. Otherwise, we can assume that the demand will reduce because maybe um, if all Americans eat just one and before they ate a lot of apples, so the consumption will decrease. But this one, because we are talking about the healthcare costs and we are trying to people be a little bit more healthy, so the consumption was low. So as a consequence, this law should affect immediately the demand curve. Remember, the exogenous events that affect a curve will make this curve shift to the right or to the left depending on the situation. If it increases, it goes to the right. If it decreases, it goes to the left. That's the case that the consumption will increase, so the demand automatically will shift to the right. Let's see this graph. So here we are talking about the Apple market. Here we have in the y-axis the price, and here we have in the x-axis the quantities. So here we have the supply, which is increasing slope, and the decreasing slope, the demand as usual. And here we have the initial situation where we have P0 and Q0 star, that those were the quantities and prices of equilibrium. Automatically, due to this law, because this is an external change to demand, then the demand will shift automatically to the right. Why? Because people will start to demand more apple due to this low demand. Then as a consequence, we will have a D prime curve, and then the new prices, the new quantities. So we will have naturally higher prices and higher quantities of apples in the market. Then, how would the law affect the marginal product and the value of the marginal product of apple pickers? So then it's important to review the previous video because you will understand automatically the meaning of the marginal product and the value of the marginal product to understand really well these questions. Then here we know that the value of the marginal product of labor is equal to the price times the marginal product of labor. Remember, the marginal product of labor is basically how much how much quantity will be produced when I hire an additional worker. And when I multiply these by the price, this is going to bring me automatically the real price or the real revenue that the producer is perceiving for that new worker. So then when the prices increase, that's the case of the apple, then the value of this marginal product labor will increase as well. Because at the end of the day, what it really matters for a producer is how much is going to bring as a revenue to me as a producer. So then if the price is going high, then automatically this value of that new worker will be higher. So that's the idea. Then this one, the marginal product of labor, remain exactly the same. How would the law affect the law affect the demand and equilibrium wage for Apple speakers. So before we had a look to the Apple market, and then we are now in the labor market. So here we have kind of different the axis, because here instead of price that we have in the Apple market, we will have here the wage, which is the price of the work, and then L, which is the labor measured as the quantity of workers. Usually this L to be a number which is it's going to be just like 1, 2, 3, 4, 5. It cannot be like decimals, right? So this is the idea. So then here we have the equal, the supply and demand, but here the demand we know that as the labor demand curve, okay? And then here we have the supply. Here we have the L star 0, which is the initial point of the part of the equilibrium, and here the W 0 star. Here, because there's is an external kind of shock of that movement, you will move this curve, which is the value margin product of labor, which is exactly the same as the labor demand curve. As a result, you will shift to the right this labor demand curve provided by an increasing of the price of the Apple market. Okay, and it makes sense. Okay, automatically when you have like oil prices that they go up, you will see a relationship as the this one at the end, the value of the marginal product of labor will increase, and as a result the wage of this industry will go up. So that's the case. Here we will hire more people, and then the wage will be higher. Okay, so that's the point, that how it affects the Apple market affect here the labor market as well. Then show the effect of each of the following events on the market for labor in the computer manufacturing industry. Congress buys personal computers for all US colleague students. Okay, then here we have the PC market. Here we have the price and this Q, the quantities of the P personal computers, and here we have the demand and supply as usual. Here we have the equilibrium, right? And due to there's going to be kind of, you need to buy personal computers for all US students, then automatically the demand for that good will increase, so will shift to the right. It automatically will bring higher prices of personal computers and higher quantities at the equilibrium. Then here, because of the value of the marginal product of labor increases due to the increase of the price, we will see the impact in the labor market for the manufacturing industry, which is the end or the purpose of that question. So here we have the wage as the price, the L as the quantity, which is the labor. Here we have the initial situation. Due to higher prices, this value marginal product of labor, or the labor demand curve, will shift to the right. As a consequence, we will have a higher workers. We will hire more people at that industry, and the salary or the wage will be higher. Okay, then more students major in engineering and computer science. So here more college students. Then we have here labor markets. We have here W and L. Here we have the situation that we have the equilibrium. So because more students they study engineering, so at the end of the day that they are the workforce, so they are the supply in this market, so then the supply will be higher because there are more and more students at that branch at engineering. So as a consequence, there will be more people at the equilibrium, but as a consequence, because of the low scarcity, because at the abundant, this abundant input, or maybe the same factor of production, the W, so it means the wage will decrease. So this is the consequence if more and more people become engineering. So that's the trick. Try to pursue a career that is very specialized and there is a demand, so automatically you will have more chances to have like higher prices or higher salaries. Then the computer firms built new manufacturing plants. So here we are in the PC market. So here we are in the demand and supply curve initial situation. Because computer firms build new manufacturing plants, it means that it goes immediately to the supply part. So due to that, uh, here I'm sorry, this is not D prime. You should be like higher supply, right? So then here you will face like lower prices and higher quantities due to this kind of change of technology, change in the supply. Then as a consequence, the price will go down, then the value of the marginal product of labor will go down as well, and then as a consequence, we have here that the demand or the labor demand curve will go or will shift to the left, because remember, when there is a change in the demand, which is the companies, this will change naturally the demand. But when we are talking about the workforce, at that time the supply, we move the supply. Okay, so this, for this reason, we will have naturally lower salaries, lower wages, and then the quantity will decrease as well. Then, 3. Suppose that labor is the only input used by a perfectly competitive firm. The firm's production function is as follows. Remember, perfectly competitive firm, we are talking about a lot of consumers, a lot of producers, and there is no incidence in the price at all. So everybody is price taker. Then here we have the table that is provided by the exercise. So here we have the days of labor and the units of output. So if there is no days of labor, naturally you will have 0 units of production. But if there is 1 day of labor, you can achieve 7 units, so on and so forth, until 7 days will bring 29. Automatically you can have a look here to the similarity to the previous part of the explanation of the chapter, where the days are increasing of labor, but the units of output, they are increasing, but not in the same rate or at the same rate. Naturally, we see here how at the 7th day, actually we have like there is no growth, and it remains exactly the same, 29. So then the first is calculate the marginal product of each additional worker. So here actually days of labor, we can think better to understand better the exercise as a worker. Then we have here days of labor as a worker, and then here we have the units of output. Here we have exactly the same information that is provided by the book, and here we are going to calculate the marginal product. So the marginal product of labor, remember, because this is a difference or a change between this one and this one, because this is like kind of in the denominator and it changes 1 to 1, it doesn't affect anything, and this one is in the numerator, and this is because it changes differently. This is actually what matters. So here we're going to put here in the middle, because it's the change from 1 to 0. So the kind of the interpretation of this marginal product of labor is like, when I hire a new worker, it will bring to me 7 new units. When I hire the second worker, automatically this will bring to the production 6 additional units. When I hire the third additional worker, it will bring to me 6 additional units. Then this one again 6, then it starts to decrease. And why? This is the law of diminishing this is of the law of diminishing production, right? The marginal labor. So here we have 1 and here we have 0. Then here is the same information that we found before, and then each unit of output sells for 10. Calculate the value of the marginal product for each worker. Then the value of marginal product of labor, remember, is exactly the marginal product of labor times the price. Then should be 10 by 7, 6 by 10, so on and so forth. And then we will finish here. Then here compute the demand schedule showing the number of workers hired for all wages from 0 to 100 a day. So here we have the wage. We have here from 0 to 100. So when we have here automatically the wage from 100 to 70, sorry, here is like kind of the cost. So we don't need to be smart enough. We just need to verify that this cost should be lower than the revenue that this worker will bring to me. So here automatically when I need to pay for each worker between this part 100 to 70, I don't hire anyone because it doesn't compensate the cost that is 70, and the production, the value of the marginal product of this one, which is the most productive, should be 70. So I won't hire anyone. But when I am between 70 and 60, I can hire one guy, because with one guy I can earn the difference between the value marginal product of labor and the wage. So this one I will hire one. When I am between 60 and 30, this one automatically I can hire 4 workers, because for example, if the wage is 60 and I basically hire 4 guys, then automatically I will take, at least for this first one, I will take a gain, a benefit, a profit, but with the others I will take just 0 profit, but at least for one I'll take benefits. So then I should take 4. Remember, this should going to be like the marginal revenue is exactly equal to the marginal cost. Here the marginal revenue is the value of the marginal product of labor, and here the price, or sorry, the marginal cost is the wage, which is constant. If I hire one, I need to pay the same value. If I hire 10 guys, I need to pay exactly the same. Then when the wage is between 30 and 10, then I can hire 5, this one, 1, 2, 3, 4, 5. And then when the wage is between 0 and 10, I can hire 6 guys, because again they will bring to me benefits. And when the wage is 0, I will hire the maximum, which is 7, where all of them, they will bring positive benefits until the last one, that this one, the 7th guy, will produce 0 as additional, okay, as additional. So then, and the wage is equal to 0, so this should be the maximum, the most efficient. Then suppose graph the demand curve. So here we have the table. Here you will see that this kind of traces, so it's not the normal demand that we usually draw, right? So here we have the wage, and here we have the salary, the labor. So here we start to graph. So here, when is the this part, the wage equal to 100, I won't hire anyone. So then should be a point here, right? So then I automatically I won't hire no one else until salary equal to, or the wage equal to 70, where I started and I hire one guy. Then when the salary or the wage is equal to 60, I will hire four guys. Then when the wage is equal to 30, I will hire five guys. And then when the salary or the wage equal to 10, I will hire six guys. And then when the wage is equal to 0, I will hire 7. So then I start to just join the points. Here will be the first part, and we can understand that because just if the wage is equal to 70 to 100, I won't hire anyone. And then this one should be to 1, then to 4, to 5, to 6, and 7. Okay? Then, what happens to this demand curve if the price of output rises from 10 to 12 per unit? Then, here is the value when it's equal to 10, and then this is the value when the price is equal to 12. And why it increases? Because remember, the value of the marginal product of labor is equal to the price times the marginal product of labor. So they should be 12 times 10, 12 times 6, so on and so forth until 12 times 12 times 0. Okay, then here we have different intervals. So here we have between 184. I won't hire. Well, those are the intervals. Basically, it's the same here, same numbers. And then when the interval is between 184, here have an important. You can understand some important fact that because the price is higher, I can allow that I'm going to start to hire people when the wage is higher, because the price is higher. So then I can offer better salaries to people. So then this should be 0. I won't hire anyone. But here, before, in this interval, when the wage it was 84, I didn't hire anyone. But here, due to the increase of the price, I can start to hire someone. So here, from this interval, I start to hire one guy. Then from this one, I start to hire four guys, and then for this interval, I hire 5, and then 6, and then 0. So then, what happens to this demand curve if the price of output rises from 10 to 12 per unit? So I automatically can make exactly the same. Before, this is the previous one. The red one is the previous situation when the price is equal to 10, and then have a look. When it's from 100 to 84, this should be 0, right? And then this one should be 1, 4, 5, 6, 7. So then 84 should be this small part. Automatically, when the wage is lower than 84, I will start to hire the first guy. Then from 84 to 72, I will start to hire the fourth guy. Okay, 4 guys. And then when it's 36, I will hire until 5 guys. Okay, from 36 to actually to 12, and then this one 6 guys, and then at the end I will hire a 7 guys. So you will see here how the demand curve shifts to the right. It's kind of different. It's kind of a stair curve, because there are intervals. Okay, so for this reason is kind of different, but the idea is basically the same. The demand shift to the right provided by the increase of the price in the market. Then Smiling Cow Dairy can sell all the milk it wants for a gallon, and it can rent all the robots it wants to milk the cows at a capital rental price of 100 a day. It faces the following production schedule. So here we have the production schedule. So here we have the number of robots, okay, which is basically kind of the capital, okay. Before exercise or the previous exercise, we had the labor as the factor of production. Here we are just considering the robots that are capital, and then here we have the production. So this is basically the same idea. If I have 0 robots, I will have an output 0 gallons. But when I started to rent the first robot, this will bring to me 50 gallons. Then the second one will bring to me 85. As you can see, all the time I increase the number of robots, all the time I increase the production. Just with the fact that every time I increase in one robot, the production increases in lower kind of rate. This is again the diminishing product of capital at that part, or the diminishing product of the factor of production. In this case, we're discussing about the capital. Then, in what kind of market structure does the firm sell its output? How can you tell? So here we are in the competitive market, okay, because the smiling cow dairy can say all the milk it wants for 4 a gallon. So this is an important fact, because it doesn't matter if you produce just one milk or 1 gallon of milk, or you produce 100 gallons. The price that you will go to the market is exactly the same, because you are a price taker. You don't have any incidence or any power inside the market. So then, in what kind of market structure that the firm rents robots? How can you tell? Competitive market. Why? Again, because this is the rental price 100A, and it is exactly the same. If I just rent one robot or I just rent 100 robots, I cannot make any change inside the price, inside the market. So I'm again price taker. Okay, so then calculate the marginal product and the value of the marginal product for each additional robot. So here we have the number of robots. It's just like exactly the same information that you saw before, and here the total product, and then the marginal product of capital, which is going to be like k lowercase, and then it's going to be exactly this difference here, because we change and one by one, which is the denominator, it doesn't matter, which is going to provide really the change is going to be the change in the total, or the change of production. So it should be 50 minus 0, 50, 85 minus 50, then 115 minus 80, 85, and so on and so forth. So here we have the marginal product of capital. As we realized before, the point is like here, anytime we produce or we hire additional robots, naturally this will bring higher quantity of production, but is going to increase less than the previous one. This is again the law of diminishing product of capital. Then here the question, how many robots should the firm rent? Explain. So here we need to take the value of the marginal product of labor, and remember the value of marginal product of labor is price times the factor of production. In this case, the price times the marginal product of production. That's true, which is in this case the capital, right? So then here we have 50 times the price of this one, which should be 4, which is the price of the milk, right? And then 35 times 4, which is going to be 140, 120, 100, okay, so on and so forth. And here is the price, 100, which is basically the wage, if you want to see that as that part. So then the point is you need to again make equal the marginal cost equal to the marginal revenue. The idea is like if you bring a new robot, this should bring to you profits. Otherwise, you are not going to pay another or an additional robot. Okay? So then you will see here, for example, this first situation, the real income that this first robot will bring to me is going to be 200, but the cost is 100. So I'll say, okay, Okay, I'm going to hire a new one. Then the second one, just by itself, this will bring to me 140. What is the cost? 100. Okay, so I guess that I can hire a new one. So if I hire a new one, we'll bring 120, and the cost should be 100. So you can say, okay, I can still hire a new one. Then this new one will bring to me 100, and the cost should be 100. Automatically, this is the standpoint. This is the point that you say, okay, I'm not going to hire more robots, because if you're like kind of stubborn and you hire a new one, this will bring to you $80, but the cost should be 100. So it's not a deal. So then you automatically will hire until right this fourth robot. Okay. Then the nation of Ectenia has 20 competitive apple orchards, which sell apples at the world price of $2 per apple. The following equations describe the production function and the marginal product of labor in each orchard. So first, we have here Q. In the book, we have like a uppercase, but I just put here a label as a lowercase because this is the orchard. Okay, Q equal 100L minus L squared, because this Q is the quantity of apples by each orchard, and this L is the quantity hired by each owner of an orchard. Okay, then the marginal product of labor is provided, which is this one. If you are familiar with derivatives, you will see that here is the derivative of Q when L changes. So it's derivative Q over L, or Q prime should be 100, which is the derivative of 100L, and L squared, the derivative is 2L. If you're not familiar with that, I recommend that you have a look to that. But otherwise, it is provided by the book. Then, here, the where Q is the number of apples, okay, produced in a day, and L the number of workers, and MPL the marginal product of labor. Here, take into account that this is the lower case, because we are talking just about one orchard, and you will see then afterwards why. Then, what is the each orchard's labor demand as a function of the daily wage W? What is the market's labor demand? So here, first, what is the each orchard's labor demand as a function of the daily wage? Okay, because we are facing here as a function of the W, then we need to kind of collect the W, and we need to take at the end L in terms of W. Okay, that is the kind of the idea. And then what is the market's labor demand? We need to take that labor demand function and convert to this market's labor demand. So here we go. Here we have the demands labor. Remember, the demands labor is provided by the value of the marginal product of labor. It's exactly equal to the price times the marginal product of labor. Here, we'll label that as a first equation. Here is the second equation, and here is the third equation. So you can say, okay, I already have the second one, which is this one, so I can insert into the third equation, right? So then we have that the value of the marginal product of labor is exactly equal to the price times the marginal product of labor. What is the marginal product of labor? Is this one, 100 minus 2L, right? Then we know that the price, because it is provided by the exercise, the price for apple is 2. Then we just replace the price equal to 2 times 100 minus 2L. I just multiply. I have 200 minus 4L right? And remember the condition of the maximization of the worker, of the producer. So we have here that the value of the marginal product of labor is equal to the wage, which is the marginal revenue equal to the marginal cost. Okay, then here we have that the W should be equal to value of the marginal product of labor, which is 200 minus 4L, right? Then remember that they say the labor demand is a function of the daily wage W. Here we have the opposite. We have the L, right? Um, Here we have the W. Uh, Basically as a function of L, right? So it's the opposite. So we are going to collect L, okay, then this one is like with minus, so it goes to the other side, okay, with positive, and then this W, which is positive, will go to the other side negative. Then because this is multiplying, you can put these 4 dividing all the expressions, so you have the L, which is the number of worker in each orchard. So you have here 300 minus W over 4, and remember this 4 goes to these both parts, and then you will have 50 minus W over 4. So this is the first question, the labor demand as a function of the daily wage. But what is the market's labor demand? You need the market labor demand, you need to take this expression and need to multiply by the number of orchards, okay? We should be exactly equal to 20. Then you multiply and you will have at the end 1000 minus 5 over times W, because this 20 over 4 is 5, and then you have this one as the market labor demand. Then you have here the same expressions provided before, and then it says Ectenia has 200 workers who supply their labor inelastically. Solve for the wage W. How many workers does each orchard hire? How much the profit does each orchard owner make? Then when we are talking about inelastically, because this is complete vertical, so it means that there is no any adjustment of the supply or any change of the price. So it means basically if the wage changes, the supply is going to be exactly the same. Anytime should be 200. It should be just a straight line vertical, right? Then here we have the market labor demand that we found before, right? Then we know that the L, or the labor, is equal to 200 because this is the total population, the total workers. And here we replace L, 200, equal to that, and we solve for the wage W. So then this 5W, which is minus, go to the other side positive, and this 200 goes to the other side negative. So then you have here 800. This one, which is multiplying, it goes to the other side dividing, and then 800 over 5 should be 160. So this is the value of the W, of the wage. Okay, then how many workers does each orchard hire? So then this one, because we will see that. And then how much profit does each orchard owner make? Let's make this one, and then we will go back to this one. Okay, so here this is the profit, okay? Total revenue minus total cost. Then the profits market should be price times Q, uppercase, L, the total workers, times the wage. Here we know that L is 200, and because we have like 20, remember that we have here we have 20 owners, right? So then each one should be exactly 10. We'll hire exactly 10. So then the quantity of each orchard should be, because this is the function for each orchard, should be 100 times 10, which is the quantity of workers per orchard, minus 10 square. Then here we have 1000 minus 100, and this is the production for each orchard. If I need to find out the production of all the market, should be because all are exactly with the same characteristics, so we are here with 20 times Q. So then should be 20 times 900, which is 18,000. This is the total production of apples of the total market. Then the profits we are going to identify by pi m as the market is equal to price times Q minus LW. Then the price is 2. The Q we already found out, which is 18,000. And then the L should be 200 because we are talking again in the market times 160. This one should be 36. This should be 32. The total profits of that market should be 4,000. And then if we are not going to make, what about the orchard owners make? Each orchard should be this one over 20. Then the profit of each individual should be exactly equal to the profit of the market over 20. Then each orchard will produce or will take for that production 200, sorry. Then here we have the same equations. Then here as the C point, before that I'm going to read, calculate what happens to the income of workers and orchard owners if the world price of apples doubles to 4 per apple. So before going to equations, remember, if this changes, the value of the marginal product of labor will change, which is basically the demand. Okay, because of that demand, the demand will shift to the right. As a consequence, we will have higher salaries, right? And higher L. But because of this part, the L is provided inelastically, the L should be exactly the same. It will be just change in the wages, and naturally will be better situation for the not only for workers but also for producers, because the price is higher. So then here let's see that into the numbers. So here we have the value of the marginal product of labor, which is equal to price times the marginal product of labor. Then we already know this one, okay, before the exercise, but now the change is like the price is 4, so we just replace here 4, and then we will have 400 minus 8L, and then we are going to find W2, which is the situation of that when the price is equal to 4. Then we have here W2 is equal to 400, right, minus 8L. Okay, we just replace this one, and then we just collect L. So then 8L move to this one. Sorry, this is lowercase because it is each orchard. Then you will have 8L equal to 400 minus W2, which is the situation of C. Then we put this 8 over, and then at the end we have this one, which is this L. Sorry, this is lowercase again. 50 minus W2 over 8, and if we want to take the market labor demand, it should be times 20. Then at the end we finish this one, okay, 1000 minus 20 over 8. We can cancel out, we can divide these 2 by 2, so then we have 10, 4, another time by 2, then we have 5 and 2. Then as a consequence, this is the market labor's demand. Then with this information, we can automatically replace the number of workers, which is 200, and we solve for wage. Then we move this expression, which is with minus, to the other side with positive sign, and then 1000 minus 200, and then you should be this one should be 800 times 2, which is this one, which is dividing, goes to the other side multiplying, should be 1600, and this 5 goes down, should be dividing this expression. Then W is equal to 312. Then automatically you grasp that when the price double, then in this case the wage double as well. Let's see if with the profit it turns the same. Then you have here W before initial should be 160, the other one should be 320, and then the profits of the market, it it was 4,000. Then it was for each orchard to 200. Automatically with higher salaries we expect that these should be higher, right? Let's see if it's the double again. So here we have L 200, and for each orchard we have 10 10. Then we just replace in the production function of each orchard. So we have 100 times 10 minus 10 square, and then we finish this one. Then the production for each orchard is exactly the same. Then the production of the total orchard is 18,000. Then the profits of the markets too, which is the situation with this condition, we have 4 as the new price, then 18,000, which is the quantity, minus 300 times the wage, which is 320. Then we have 72,000 minus 64,000, and then the total profit of the markets with these new prices, we have 8,000. It's double the same. It's double as the wages. Then naturally, if we have here the situation 2, which is it represents the situation with the price equal to 4, then should be 8,000 over 20, and then we figure out that the profits for each orchard increase as well. Then the last part, now suppose the price is back at 2 per apple, but a hurricane destroys half of the orchards. Calculate how the hurricane affects the income of each worker and of each remaining orchard owners. What happens to the income of a hectare as a whole? Then you automatically, without numbers, you can understand what's going on. When there is a problem with this one, with the land, then automatically you can figure out how the land market will change, right? So this provided because this one will change, the supply of the lands automatically decrease, right? So then the supply will go to the left, and due to that the prices of the land will be higher, and naturally the quantity of capital will be lower, right? And then as a consequence you will see how the demand will decrease, and because L is exactly the same in this example, because inelastically the L should be remain exactly the same. Now let's go to the numbers. Then here we have the situation, and then because we know that this should be half of the orchards, the quantity should be over 2. So this is the trick. If you understand that the quantities, so the production function will be half, automatically you are in. You need to understand economy. If you think like different difficult computations, most of the time it's wrong. So you need to first understand really well the exercise, and you can see here the QD, which is associated with the problem, is equal to the Q over 2. So then you have 100 minus L squared over 2, and then the QD is equal to 50 L minus L squared over 2. And then the marginal product of labor is derivative of that. So then should be derivative of 50L should be exactly 50 minus L, because this one 2 goes down, and then should be 2L over 2 should be L. Okay, so this is the situation. If you maybe still not okay with that, you automatically see how the marginal product of labor will be split by 2 as well. So here you have the marginal product of labor, and you start all the process. First, we have that the value of the marginal product of labor, D, is equal to the price times 50 minus L. This one, the price is 2. Then you replace this one, and then you have 100 minus 2L. Then you know that the condition is that the value of the marginal product of labor is equal to the W, in this case WD, which is the situation associated with D point or D exercise. You replace, and WD is equal to 100 minus 2L. Then you collect L okay, what you have here is you collect this one to the left, W to the right with minus, and you make all divided by 2, then you have 100 over 250 and WD over 2, okay? Then the market labor demand, you need to multiply then by 20. This is the number of owners of orchard. Even the territory makes half, you assume that they are still 20, just like the territory is half. Okay, then you multiply, and then you have this one. This is the new labor curve demand, which is naturally, if you graph that, should be lower than the previous one. Then L is equal to 200, workers remain the same, remember it's an elastically curve. Then you replace 200, you collect by W, and then you have 10 WD equal to 1000 minus 200. You collect, so just divide, sorry, double this 10, and then at the end you have 1000 minus 200, 800 over 10. You have the salary 800. It goes automatically. Before you see, or you saw how it double. Then at this occasion, the salary, the wages they have, and then the profits is equal to the total revenue minus total cost. The profits of the market is equal to the price times Q minus LWG. So we are talking about the total market. So before we need this Q, remember L is equal to 200 and LD. So this equation of L should be 10 for each orchard, and then we just replace then this curve. The production should be 50 times 10, and then minus 10 square over 2, and then you have 200 minus 50, and then the production of each orchard is 450, which is automatically half of the previous one, and then times 20. Just here the previous values that we already found, the total Q, which should be 450 times 20 should be 9,000, and then the total, the profits of this situation should be P times Q, which is P times Q, which is exactly minus LWD. This is the situation of all markets. You just replace P is equal to 2, the total production is 9,000, L is equal to 200, and WD is equal to 80. Then should be 18,000 minus 16,000. So the total, the benefits of markets in situation D should be 2,000, which is half of the previous situation. And then the situation of each orchard should be exactly half, should be exactly the same. Okay, I hope you could grasp this exercise. I know that it's kind of tricky, but if you follow steps and you understand what they're asking and the information that you have, I guess that you can go. Okay. That's all for today. If you have another way maybe to answer this question, this is kind of subtle. This is my point of view. Maybe I'm wrong, but this is how I understand this kind of exercise. I'm really happy to have you in my channel, and that's all for today. Okay, bye bye.